How many jelly beans are in that jar? Or how much does that apple weigh? Or how far is that star away from the moon? In most cases, we'd be perfectly happy to just make an estimation for these types of questions. My name is Miss Danielson, and today we're doing estimating by rounding. I hope you joined us for our previous lessons on rounding to place value, rounding to decimal places, and rounding to significant figures, because that's going to help us to complete these estimations today. If you missed those lessons, check out the description box below. I'm linking them down there for you. Let's get started. When we estimate the answer to some calculation, we're finding an approximate answer. I don't really like to use the word guess because there's not much value in simply guessing at an answer without at least considering the information given. So in order to make an appropriate estimate or approximation, we're going to use rounding to some degree of accuracy. Whether you're going to round to some place value or significant figure or number of decimal places. For example, 487 is approximately 490. That's when I round to either the nearest 10 or to two significant figures. I could have rounded this value in a different way as well, however. 487 is also approximately the same as 500 when I round to the nearest 100 or to one significant figure. But one thing to keep in mind whenever we round or estimate or approximate an answer is that we make a rounding error. Saying that 487 is approximately the same as 490 is making a rounding error of 3. That doesn't mean that we rounded incorrectly. It just means that our answer is 3 away from the actual answer. When we rounded 487 to the nearest 100, saying that it's approximately the same as 500, the difference between our answer and the true answer is 13. That doesn't mean that we made a mistake when we rounded. It just means that by rounding, our answer is not 100% correct. We could have rounded 487 in another way as well, although I hope that you wouldn't. We could say that 487 is approximately the same thing as 0 to the nearest 1,000, because of course 487 has 0 in the thousands position, and a 4 to the right of that is not big enough to round that 0 up. But the rounding error in this case is huge. The difference between 487 and our approximated answer, 0, is 487. So although we may use rounding to approximate our answers, to make them easier to work out, be very careful with how much you're willing to round off. We still want our answers to be somewhat accurate. Let's try another example. 4.0627, or 4 and 627 tens of thousands, is approximately the same as 4. And I would expect that you would probably want to round this to the nearest whole number, or one significant figure, or 0 decimal places, as we have, because that was a fairly long decimal number to write down. Now, since this was a decimal number, my rounding error is not as big as they were above. The difference between 4 and 4.0627 is just 627 tens of thousands. That's really quite a small rounding error. But I could round this in a different way to keep that rounding error even smaller. If I rounded this to the nearest tenth, or two significant figures, or one decimal place in this case, that would only be a rounding error of 373 tens of thousands. That's almost half of the rounding error as above, because I'm rounding off fewer digits this time. I could keep that rounding error even smaller if I rounded to the nearest hundredth. That is, where the 6 was, I saw there was a 2 next to it, so the 6 did not round up, and I say that 4.0627 is approximately the same thing as 4.06. This time, my answer, which is to 3 significant figures, or 2 decimal places, only involves a rounding error of 27 tens of thousands. That's just a tiny, tiny little rounding error. Although it would be easier to work with the value 4 than the value 4.06, rounding off fewer digits causes a smaller rounding error. Nonetheless, when you're asked to estimate an answer, you just need to work it out the easiest way possible, so long as your answer is fairly accurate. And what's most important here is that you've got the correct place value. Notice in each of these cases, the 4 is in the units position. I'm going to move forward assuming that we know how to round, both to decimal places, significant figures, and place values. If not, you're going to need to check out the links down below. But we've been over rounding, we've been over the rounding error that this could cause. Let's now just quickly go through when we might estimate a calculation, rather than performing it accurately. Sometimes it's not necessary to find the exact value, like the exact distance between the moon and some star, for example. We're most likely going to work with rounded values. Also, some calculations may be too difficult to complete mentally, so we'll try and make them easier by rounding the values that we're working with. And thirdly, we could use estimations of calculations to make sure that the answer that we've worked out is reasonable. Even if we're using a calculator, you could have made a mistake either with the functions that you've used, or you might have simply typed the values in wrong. Estimate the answers to these calculations by first rounding the values as most appropriate for the question. As they're leaving it open to you, you should round these values in a way that's going to make it easy for you to perform the calculation. You may be thinking, I can perform those calculations mentally no problem, just by doing some working out. Question A might require column addition, or if we round these values, so we could just easily add together 30 plus 40, mentally, that's 70, and get a pretty good idea of what the answer would have been if I calculated it accurately. Now you might be thinking, 30 plus 40, yeah, that's easy, that's 70, but I'm sure that gave us a rounding error. Anytime we round, we're going to produce some kind of rounding error, but maybe we didn't need to round quite so much. Now, I would imagine that you could all add 29 plus 43 together, although it will be a little bit more difficult. Column addition would help, but if we can do this mentally, starting with the units, 9 plus 3 is 12. So remember that 2, you might want to write it down, and hold on to that 10 in your mind. Because when we do 20 plus 40, which is 60, remember to add that 10 in, so 70, and the 2 that we already had. Now this estimate should be a bit closer to the actual value, but in either case, we know that the correct answer must be somewhere close to 70 or 72. For question B, again, I'm sure you could do long multiplication for this, however, you don't need to. Try doing a multiplication of two values that are easier to work with than these ones. 200 times 50 should be a nice, easy calculation for you, especially if you ignore the zeros to begin with and just do 2 times 5, that's 10. But this isn't 2 times 5, this is 200 times 50. So you're going to need to multiply your answer by 100 as well as by 10. So tack on 2 zeros and then tack on an extra 0, that's 3 zeros altogether. That's 10 with 3 extra zeros after it. 10,000. Now we did quite a bit of rounding to work that out, but that was a nice, easy estimate. If you're concerned that your answer is not accurate enough, you might have noticed that it was quite easy to multiply by 50. But the 182, I didn't need to round as much as I have. I could keep that as 182 times 50. Do you know the tricks of multiplying by 5s, 50s, 500s, and so on? Notice that 5 is the same thing as 10 divided by 2, and 50 is the same thing as 100 divided by 2. You should very easily be able to multiply by 5s if you can easily multiply by 10 and divide by 2. So by that logic, you should very easily be able to multiply by 50 if you can easily multiply by 100 and divide by 2. In this case here, we want to do 182 multiplied by 100 and then divided by 2. Or if you find it easier, divide by 2 and then multiply by 100. 182 divided by 2, so halved, is 91. Times that by 100, 9,100. Now this estimate should be closer to the actual value, because if you see in blue, we rounded the 182 up and we rounded the 47 up by, so 10,000 will be an overestimate of the actual value, while 182, which is accurately the same, multiplied by 50, which has been rounded up, means that 9,100 is a slight overestimate, but certainly not as much as 10,000 would be. Still, if you found this difficult, they never specified how you needed to estimate, so you can stick with the easier values if you like. The important thing is that both of our answers are quite close to 9,000 and 10,000. For question C, divisions tend to be more difficult to work out, especially ones like these. 47.5 divided by 2.43. Working with decimals tends to be difficult, so let's round these. 48 divided by 2 shouldn't be too difficult for you. Dividing by 2 is just the same as halving, and half of 48 is 24. Now that was relatively easy. We could have worked out a closer estimate by doing 48 divided by 2.4. Now I know what you're thinking. Dividing by a decimal number, that's difficult. But if you know the tricks of dividing by decimal values, that is, treat that decimal value like it's a fraction. 2.4 is the same thing as 24 divided by 10. That's how we've moved the decimal over. So to divide by 2.4 is the same thing as to divide by the fraction 24 over 10. Now it should be clear that you're dividing by 24, but what are you doing with the 10? To divide by a fraction, you should remember about cross multiplication. We're going to divide by the 24, but we're going to multiply by the 10. Cross multiplication means multiplying by that fraction flipped over, so the inverse of the fraction. I've put the 10 on top and the 24 on the bottom, and I'm multiplying. So basically I'm doing 48 times 10, and that answer divided by 24. Or if you prefer, 48 divided by 24, which is 2 times 10. That's 20. Again, this will be a closer estimate to the actual calculation, but if you're finding this too difficult to do, we're not told that how accurate we need to be, so you could have just done it the blue way, and you can see both answers are about 20. As we said before, we may estimate to work out calculations that are too difficult to complete mentally, or we might use estimations to check our answers that we've already done. So these calculations were already worked out, but I don't know if they're right or not. Let's do an estimation to check. 287.2 divided by 1.8. I wouldn't want to do that mentally, but I'm told that the answer is 15.95. Does that sound right? Keep in mind that 287.2 is about 300, and 1.8 is about 2. Does it make sense that 300 divided by 2 would be about 15.95? 300 divided by 2 is 150. So clearly we got some kind of a place value error here. Maybe the true answer was supposed to be 159.5. We don't know by our estimation, but we definitely know that this is wrong. Let's try this next one. 67.2 times 0.15. Again, this multiplication, which has got decimals in it, it's going to be difficult for me to do in my head. I would at least need to write it down. But does it make sense that it would be approximately 10.08? Let's try an estimation to check. 67.2 is approximately equal to 70. and 0.15 is approximately equal to 0.2. So 70 times 0.2. We're still multiplying by a decimal value, but it might help if you keep in mind that 0.2 is the same thing as 2 in the tenths position. That's the fraction 2/10. So we're going to multiply by 2 and then divide by 10. 70 times 2 is 140. 140 divided by 10 is 14. So 10.08, although it's smaller than 14, could be correct. At least we've got that 1 in the correct place value. Now, although the 10.08 is smaller than the 14, I do still think that that could be the correct answer, because at least we've got the right place values here. The 1 is definitely in the tens position. And when I performed my estimate, I did round the 67.2 up to make 70, as well as rounding the 0.15 up to make 0.2. So it makes sense that my estimate is bigger than the actual value. So I'm going to go ahead and say that I think that's right. Question C, again, is a difficult division with decimal values. But does it make sense that 27.02 divided by 1.6 is 1.68875? Keep in mind that 27.02 is approximately the same as 27, and 1.6 is approximately 2. Half of 27, that's 13.5. Or if you still find it too difficult halving an odd number, we could also say that 27 is approximately 30, so 30 divided by 2, which is of course 15. In either case, both of my estimates are quite a bit higher than the value that they gave me. And although my estimate in part B was bigger than the given answer, these estimates are much bigger than the given answer. The 1 in the answer they gave me is in units, while in both of my estimates, the 1 is in the tens position. So maybe the correct answer was 16.8875. But I think they must have at least made a mistake with the placement of that decimal. So I'm going to say that this is wrong. Let's go into some practice now. Go ahead and copy these questions down and make sure you show your working, because you could estimate these answers in many different ways. For question 1, you're going to estimate the answers to these calculations first by rounding the values as most appropriate for the question. Just round them in a way that'll make it easy for you to work out the answer. For question 2, the calculations have already been carried out, but some of them are definitely wrong. Again, copy the question as well as the given answer and show your working by rounding the values in the original question and working out your estimate. Go ahead and hit pause so that you can do that now, and hit play when you're ready to take it up. I hope you've had a chance to hit pause, because here come your answers. For question 1A, you may have rounded these to 40 times 70, or 40 times 72, or 38 times 70. In any of these cases, you've got some answer which is 2,000 something. The actual answer is 2,736. So regardless of how you estimated your answer, in any of these 3 methods, they would be fine. So make sure you've shown your working, you've explained to me how you've estimated your answers before we go on checking the rest. For question B, we could have rounded that to 2 times 4,000 or 2.5 times 4,000. Either way, the answer should be approximately 10,000. Question C, you could have rounded to 20 times 0.5. That's a nice easy calculation, half of 20. Noticing that 0.482 is approximately a half, you could half just about any value. So 6.38 times a half is 8.19. That would be a closer estimate. The actual value is 7.89516. Regardless of how you estimated this answer, you should have found that your estimate is a bit less than 10. For question D, we might estimate this as 4,000 divided by 20, which is a nice easy calculation, or 3,600 divided by 20. In any case, the correct answer is approximately 149.54. For question E, we could have done 50 divided by 2, or 48 divided by 2, which would be even closer, or 48 divided by 2.4. Again, remembering how we divided by decimals, 48 divided by 24 times by 10. In any case, the actual answer is approximately 19.55. So regardless of your estimate, you should have had something around 20. Question F, you could have done 0.8 divided by 0.4, or 0.816 divided by 0.4. In any case, your answer should be approximately 2. In question 2, working out which answers are definitely wrong, well, let me just go ahead and tell you. The first one is correct, and the estimate you might have done for that would have been 25 divided by 2, which is 12.5. Question B, this one is definitely wrong. Check out my estimate. 1,407 is approximately 1,000, and 0.017 is approximately 0.02, or 200ths. 1,000 times 200ths is the same thing as 1,000 times 2 divided by 100, so 2,000 divided by 100, which is 20. Definitely a place value error there. For question C, I'm going to go ahead and say I think this is right, because if I'd rounded this and said this was 0.5 divided by 2 thousandths, which is 0.5 divided by 2 multiplied by 1,000. 0.5 divided by 2 is 0.25, times that by 1,000, that would be 250, which is pretty close to 320. At least the place value is about right. It's not 3,000, nor is it 30, so I'm going to go ahead and say I think that's right. How did you do with that? Are we getting the idea of how to estimate and how it could be helpful now? I hope so. If you're having any trouble or any doubts, please let me know down in the comments section so I can help you out with that. Otherwise, well done, keep practicing, and I'll see you soon.